Hello Lamai. With the last lesson, we had discussed about the two reaction mechanisms involving the alkyl halides, right? So the major two reaction kinds of alkyl halides. The characteristic reaction kind was the nucleophilic additions. Then we had discussed about another reaction kind as the elimination, right? So those are the two types of reactions available with the alkyl halides regarding our A-level syllabus, right? Today, we are going to discuss some more concepts, some more things about these two reaction types, the nucleic substitutions as well as the elimination reactions of alkyl halides, right? First, let's start with some special things you should know with the nucleic substitutions, right? So these are the ones we have learned last week with the last lesson, right? So when it comes to nucleic substitutions, we had learned two reaction mechanisms, right? So if you are to think of the primary alkyl halides, if you're looking for the primary, if you are to think of the primary alkyl halides, right, they will undergo the nucleophilic substitutions via the one-step mechanism, right, like this. And when regarding the tertiary alkyl halides, right, they undergo the nucleophilic substitutions with the two-step mechanism, right, like this. First the carbocation is formed and then the nucleophile will attack, right? Then what about the secondary alkyl halides? What happens to the secondary alkyl halides? Let's discuss about that thing, right? So let's come up with some examples, right, about the secondary alkyl halides, deciding the mechanism of the secondary alkyl halides, right? This is regarding the nucleic substitutions of secondary alkyl halides, right? Nucleophilic substitution of secondary alkyl halides, right? Let's discuss about that thing, right? Okay, so secondary alkyl halides can undergo the nuclear substitutions via the one-step mechanism as well as the two-step mechanism, right? Okay, let's discuss how to select which type of mechanism, the SN2 or the SN1. The SN2 the one-step mechanism, SN1 is the two-step mechanism. Which kind will prefer by the secondary alkyl halides, right? Actually, that will be decided by the reaction conditions, right? Whether your secondary alkyl halide going through the one-step mechanism or the two-step mechanism, that will be decided by the reaction conditions, right? Let's come up with some examples here, right? So example 1, right? Right, what we know is actual lamine. If you think of a two-step mechanism, the carbocation mechanism, basically you should be able to form a stable carbocation to go through that mechanism, right? So that is the normal idea what we have learned now, right? So what we have learned is normally, right, the compounds, right, which can form a stable carbon. One can see this as the alkyl halide, no? The alkyl halide. The alkyl halides, which can form a stable carbon, actually can go through the two-step mechanism, right? That is what we have learned last day, no? The carbon mechanism. The alkyl halides which are unable to form a stable carbocation prefers the one-step mechanism. This is what we have learned, Lama. So this mechanism is also known as the SN1 mechanism, and this is also known as the SN2 mechanism, right? If you need some examples, right? If you need some example, you can say the tertiary carbocations, tertiary halides. For example, here primary alkyl halides, now we are going to discuss about the secondary alkyl halide, right? So the idea is clear now. Now let's discuss about the secondary alkyl halides, right? Like this. So if your carbon is with the halogen containing carbon is with two R groups, these are referred to as secondary alkyl halides, no? Right? When you have two R groups like this, these are referred to as secondary alkyl halides. Right? So what kind of mechanism this thing will prefer? That is our first discussion here, right? As I earlier said, this will be defined by the reaction conditions, right? First, we are going to discuss about the solvent effect. Here, right? So example 1 is about the solvent effect. Right? Solvent effect. Right? The idea is this. So if you are to do the experiment in a polar, if you are to do an experiment in a polar solvent, with a polar solvent, you will do the experiment in a polar solvent like aqueous medium. What is a polar solvent? Right, then the carbocation which will form can be stabilized with the use of the charges appearing with the polar solvent. Right, polar solvents are like this. So if you take a aqueous medium, right, so with your polar solvents, right, you are with negative deltas and positive deltas appearing with the molecules of the solvent. So these negative deltas can be used to stabilize your carbocation. to stabilize your carbocation forms, right? So deltas can be used to stabilize the carbocation, right? So we can say, right, positive charge, positive or the electron deficient carbon can be stabilized by negative charges of medium, right? So that as carbocation can be stabilized with a polar solvent, the SN1 mechanism, the two-step mechanism will be preferred. The SN1, the two-step mechanism will be preferred, right? As you can stabilize your carbocations with the use of the charges appearing with your medium, right? These charges can be, basically the negative charges can be used to give some electron density towards the electron deficient carbon, so that that carbon can be stabilized, right? So with polar solvents, the carbocation which will formed by the secondary alkyl halide, the secondary carbocation can be stabilized, right? So that two-step mechanism will be preferred, right? So what about if you are using a non-polar solvent? Non-polar solvent, like benzene, hexane, so medium won't have any charges to stabilize the carbocation, right? So medium won't contain enough charges to stabilize the carbocation. No ability to give some electron density towards the electron deficient carbon as hexane, like non-polar solvents. In such as non-polar solvents won't contain any kind of charges there, so carbocation can't be stabilized, so you are not be able to form an stable carbocation, the alkyl halide which are unable to form stable carbocations, so that those will prefer that situations, the secondary alkyl halides will prefer the one-step mechanism, right? That is what happens, right? With a polar medium, it will go to a two-step mechanism, the nuclear substitution. In a non-polar medium, the nuclear substitution will occur, right, through a one-step mechanism, right? Okay, if you need some examples for this thing, right, see, I'll give you some example. So you can write like this. So this kind of question could appear, right? Give the product with the mechanism for the following reaction. Say this kind of question is asked, right? A secondary alkyl halide, right? Reacting with a polar reacting with a nucleophile in a polar medium, right? See, reacting with this nucleophile in a polar medium. Right? Then what kind of product you need to come up with? Basically, to come up with the product, right? No need of thinking of the medium in this case, right? As it's a nuclear substitution, right? You can come up with the product, right? So this carbon, the electrons in this carbon will attack to here, and this one will leave, right? That is the idea, right? So the product is going to be then so two of these, right? That carbon will connect this nucleophile, right? And the Br minus will leave as NaBr, right? This is the product. So if they have asked you to come up with the mechanism, now it's the time to use our knowledge what we have gathered just now, right? So this is a polar medium. This is a polar medium, right? So that the carbon can be stabilized. Carbocation can be stabilized. That means you can go to a carbocation mechanism. That is a two-step mechanism. You should decide that, right? So, with the use of two-step mechanism, we are supposed to write the mechanism here. It is secondary alkyl halide, right? If it is a primary alkyl halide, you can definitely go to the one-step mechanism. If it was a tertiary alkyl halide, you can definitely go to a two-step mechanism. But if it is a secondary alkyl halide, so then you have to think of the reaction conditions basically, right? So as you are using polar medium, as it can stabilize the carbocation, right? You will go to the two-step mechanism, right? So just let's write the mechanism here, right? Let's we can copy the mechanism now, right? Let's write the mechanism, the two-step mechanism. First thing happens is actually the formation of the carbocation by removing the halogen, no? That is the first thing happens, no? This halogen will leave and forms the stable carbocation. This is the first thing happens with the carbocation mechanism, the two-step mechanism. This is the leaving group, right? After that, the nucleophile will attack. It can be attacked by top even as well as this nucleophile can be attacked from top or from the bottom, right? Like this. So with this you will form the product. So this is just going to the carbocation mechanism. to come up with the product, the two-step mechanism, right? Okay, that has been decided by this medium in this case, because it's a secondary carbocation, a secondary alkyl halide. It can go through the one-step as well as the two-step pathways, right? Depending on the chemical environment of the reaction, right? So here it's a polar medium that they have used, so that you can stabilize a carbocation if it is to form, right? So a two-step mechanism, right, can be used to form the products, right? So this is possible as the carbocation can be stabilized by the medium, as it's a polar medium, right? No? Okay, that is how we are supposed to decide the mechanism of a secondary carbocation if the polarity of the medium is given. Right? Okay, let's discuss about the mechanism involving secondary alkyl halides when an observation is given. See, this kind of question could be asked, right? Let's think of another special kind of a situation, the example 2, right? This is another example. Regarding the secondary alkyl halides, the mechanism, right? Let's discuss this kind of example, right? This is the predicting of the mechanism with the use of the product actually stereochemistry of the product. Right, let's copy this example now, right? Let's assume, right, you have provided this kind of a alkyl halide, which is secondary alkyl halide. So you have C2H5 here, some hydrogen and a Br, basically optically active secondary halide. So secondary halide, secondary alkyl halide, which is optically active, right? Okay, let's say after doing a nucleic substitution reaction, like this, see, you are adding some OH minus, right? You are adding some OH minus, right, for nucleic substitution. Right? After doing this reaction, let's assume only one form is produced, like this. Say this is the D form, of the optical active compound, and let's assume only the L form is produced. Let's assume only L form is produced, right? What is the idea? It's like this, Lama. if you are to think of the stereochemistry of this thing, right? If you think of the stereochemistry of this thing, so we can write the same compound like this now. So you can write the same thing with the use of the stereo knowledge, right? Like this now. Right, you have some VR, right? So if they have said that only the L form is produced, that means this L form is the other form, right? L form, only that form is produced, right? Then we can say this thing is went through the one-step mechanism. This thing is went through the actually one-step mechanism, right? What we have learned with the one-step mechanism is actually, right, from the other side of the BER, not from the BER containing side, from the other side, the nucleophile will attack. For the one-step mechanism, the nucleophile will attack from here, from the opposite side of the BER, the nucleophile will attack. So definitely you will come up with the other form. If you are starting with L form, you will come up with the D form by this kind of attack. So only the other form, the L form, is produced if you are to attack by a nucleophile of a secondary alkyl halide with optical activity. Then definitely it should go through the bond-step mechanism. It should go through the bond-step mechanism, right? You can say it should go through the bond-step mechanism. SN2 one-step mechanism, right? So if you need the mechanism, you can copy this now. So you have this thing, right? From the other side, nucleophile will attack, right? So that OH will appear. If the BR appears at the right hand side, the OH will appear at the left hand side, right? That is how this thing is produced, no? This will be attacked from here. All these things will shift to this side, right? So that is the one-step mechanism, right? If this is the D form, so this could be the L form. These are not the mirror images of each other, right? It's a D form of the alkyl halide. This is the L form of the alcohol. That is the idea. So with the use of stereochemistry, you can identify the mechanism, whether it is going through the one-step mechanism or the two-step mechanism, right? How to identify a mechanism went through the two-step mechanism? By seeing the products. Let's discuss about that thing as well, right? Like this now. So if the two-step mechanism is used, right, definitely you will come up with a mixture of D and L forms with this kind of a optical active alkyl halide, right? So if mixture of D and L forms are given, are produced, most probably racemic mixtures, racemic mixtures are the mixtures containing equal amount of D and L forms, 50% of D form and the 50% of L form, right? Then it should be due to the two-step mechanism. Definitely should be due to two-step mechanism, right? So it means if you are coming up with this kind, right? L form as well as the D form like this. Right? Then definitely it should be due to the two-step mechanism, carbon mechanism, SN1. Right? So how could this happen? Let's discuss about that thing as well. Right? The idea is this. Right? So you are starting with this. It is from racemic mixture. Right? So it's like this now. You are starting with this. And at the first step, this Br leaves now. Br leaves, right? By forming this carbon. Forming carbon, the Br, the leaving groups will leave, right? Then two types of nucleic attacks are possible. With this one, two types of nucleic attacks are possible. Right? If you think of this species, right? Two types of nucleic attacks are possible. Right? Two types are possible. What are the two types of nucleic attacks possible? It's like this lamine. So nucleophile can attack from the top of the carbon. It's a planar molecule, no? It's just a trigonal plane molecule. So the carbon can attack from the top. Nucleophile can attack from the top like this. Right? Then you will produce something like this. right? Or else the nucleophile could attack from the bottom as well. From the bottom as well, right? Like this. So that what will happen? So you would produce, right, something like this. CH3 comes here, this H, and this is C2H5, this is OH. Right there, if this is referred to as your D form, this could be the L form. Right, two things are mirror images of each other, right? So that is clear, no? So if you have to discuss this thing, the OH will appear here, right? If you have to put the other things, it will be like this, and C2H5 will be here, and the CH3 here, no? The same molecule, no? Right? Okay, D and L forms are formed so that it has went through the carbon mechanism. Clear, right? Okay, that is the idea. So with the use of the products formed, you can predict the mechanism. Right? That is the second thing here. Right? We had discussed. Right, no? Okay. That is how we are supposed to come up with the type of mechanism when a secondary alkyl halide is given. Right? When a secondary alkyl halide is given. The idea is clear, no? Right. Okay. That is the end of the first discussion, right, about the alkyl halides mechanisms. Right. The next thing. Next we are going to discuss about how to predict whether elimination reaction will occur or a kind of a nuclear substitution will occur. So we should be able to predict that thing as well. Let's discuss how to predict such a thing, right? Okay. Right. Let's discuss that thing as well. How to predict whether a nucleic substitution or elimination will occur. And for that, right, we can use this thing, this theory part, what it says, right? So this theory part says, which is appearing in your page number 7, right? It says that the nucleic substitution and the elimination are competing reactions in alkyl halides. The balance between the substitution and the elimination is influenced by the solvent we are going to use, right? That is what it says. So whether a nucleic substitution or a elimination to consider will be decided by the solvent again, right? See this example, right? How the solvent affect for this selection, right? The idea is this. So you have alkyl halide here, right? You are adding the same compound, the OH minus, the same compound, the same reactant, the OH minus, right? when you are using aqueous medium, major product is going to be the nuclear substitution product, and if you are to use the ethanolic medium, the major product is going to be the elimination product, right? So basically, this is what they have observed. This is what they have observed when adding the same OH minus, the same reagent in two different solvents, right? So it's like if you are to add the aqueous KOH to this alkyl halide, you would observe like, right, 70% of the alcohol, which is the nuclear substitution product, and 30% of the alkene, which is the elimination product. And if you are to use the KOH in the same with another different solvent like ethanolic medium, you will observe, right, 70% of alkene, which is the elimination product, and some 30% of alcohol, which is the nuclear substitution product. So actually, the major product is defined by the medium then. If you are using ethanolic medium, the major product is going to be the elimination product, and if you are using an aqueous medium, the major product is going to be the nuclear substitution product. Keep that in mind, right? So that is the solvent effect, right, on deciding whether a nuclear substitution or an elimination to occur, right? Earlier we had discussed how the solvent will effect for a secondary alkyl halide, right, to which mechanism to go through, right? And here we are discussing how the solvent will effect for the product to decide whether it is the nuclear substitution or the elimination. Right, let's come up with an example. Let's come up with an example for this one, right? So next page, right, is with some questions. Let's try to solve for few, right? So first one, it says write down the major product of the following reactions and give the mechanisms as well. Let's first try to come up with the major products here, right? Major products of these reactions with the use of the solvent, right? Major products, right? Sorry. Okay, so I'm supposed to come up with the major products here, right? I'm going to use the solvent for that thing, right? First one. Here, you are adding OH minus in the aqueous medium. You are adding OH minus in the aqueous medium. So, the aqueous medium is used. That means it should be the nuclear substitution. It should be the nuclear substitution. The product should come up with a nuclear substitution. So, let's write the product in. Nuclear substitution product means just this OH minus will attack this carbon and this thing will leave, right? That is how nuclear substitution occurs. So your product is going to be this. Just instead of the Br, the OH minus will substitute. Major product. Nuclear substitution product. Okay. Think of this as well. The second one. First, let's write the major products here, right? So it is again aqueous medium. So nuclear substitution, right? So nuclear substitution means you're supposed to come up with the alcohol again, right? Alcohol again, as this thing is attacked like this, ultimately this will leave, right? Anyhow, so this is the possibility. We have to decide whether the one step or two step mechanism will occur. We'll decide that thing later. First of all, let's try to come up with the major products here. Nuclear substitution product. What about this one? See, ethanolic medium is used. So we are supposed to come up with the elimination product. Alcoholic medium, eliminations are preferred. So elimination product is means is OH minus is going to attack to this delta positive hydrogen, right? So not that hydrogen, right? But hydrogen with the adjacent carbon of the carbon bearing the bromine, right? So to this hydrogen, so not to this carbon but to this hydrogen, right? The attack will occur to this hydrogen, right? And that thing will leave ultimately. Right? Forming you kind of a alkene, no? Alkene. That hydrogen will leave. With this Br, these two guys will leave. Right? So that you will get a double bond at that space. The elimination product. Where OH minus acting as a base. As a base, it will attack. In this case, as a nucleophile. These things will attack. Right? Even with this one, you are supposed to come up with the elimination product. That means again the alkene, this Br will leave with one of the hydrogens here, hydrogens of the adjacent carbons of carbon bearing the bromine, right? So you will come up with something like this. As this carbon is with three CH3 groups, one of the hydrogen of the adjacent carbons will leave with that Br, right? Earlier you had a Br here with CH3 here. This Br will leave with one of the hydrogens, right? So this is the alkene, the elimination product. So like this, you should be able to come up with the product, right? What about this one? Again, ethanolic medium is used. So again, elimination is preferred. Right? So that this Br will leave with one of the hydrogens of the carbon adjacent to the carbon Br in the halide, right? So from these three carbons, the carbon which contains the least number of hydrogens, this thing, that thing will leave. That is how elimination will occur. Remember the Sri Lanka style, right? So this will be removed, right? Left, right? So we can come up with a product like this. This is how you are supposed to come up with the product, right? By just looking at the medium. So that hydrogen left, right? So that no hydrogens there furthermore. The product would be like this, right? So got the idea. So by looking at the medium, you should be able to come up with the product, whether it is a nuclear substitution product or the elimination product. Nuclear substitution product means the where the nucleophile connects to the carbon instead of the halogen. Elimination means you are coming up with the alkene by removing an HBI molecule, HX molecule, right? Okay, that is the idea. Then they are asking about the mechanism as well. They are asking about the mechanism as well. How to come up with the mechanism then? To come up with the mechanism. So you don't have any choice with the elimination mechanisms. only one kind of elimination mechanism is available. But when it comes to SN mechanisms, the one step and the two step mechanisms are available. So how to predict that thing? How to come up with the one step, or how to decide whether the one step or the two step mechanism is preferred here? For that, what we need to look at is the situation with the alkyl halide. As we have decided, this is a SN type of mechanism, as this one is a primary alkyl halide. This one is primary alkyl halide, right? Only one R group is with this carbon, primary alkyl halide, so that one step mechanism preferred. One step mechanism preferred. Primary things prefer one step mechanism, that means SN2. Right? With this one, as is a tertiary alkyl halide, if a nucleophilic substitution do occur, definitely it will go to two-step mechanism, that means SN1. Carbocation mechanism, as you can form a stable carbocation there, right? So you have to write the mechanism for this reaction as a one-step nucleophilic addition. You have to write the mechanism of this reaction as a two-step nucleophilic addition. With this one is the elimination, right? With these things, as well as you could go through some eliminations, right? So that is how you're supposed to predict or decide which mechanism to occur, right? Right. Okay. The idea is clear. Let's come up with other stuff as well. Next one. So we have few more. 6th case. Let's try to come up with the product and the correct mechanism here. So here they have used ethanolic medium. Ethanolic medium. So we are looking for elimination. Elimination means this Br should leave from with this one. This is the same thing which we have discussed last time around. Yeah? Okay, that is done. No? Right. And this one, again we are dealing with the ethanolic medium. So we are normally looking for a elimination. We are looking for elimination, right? So elimination means this Br should leave with one of the hydrogens of the adjacent carbons to the halogen bearing carbon. So the adjacent carbon is this, the halogen bearing carbon, but that guy is not with any hydrogens. That guy is not with any hydrogens, so that you can't think of elimination there. As this carbon is not with any hydrogens, as this carbon is not with hydrogens, no elimination. No elimination possible. So even though you had used an ethanolic medium, we are looking for the even though we are looking for the elimination, then still it can't occur, as this adjacent carbon bearing the halogen won't have any hydrogens. So elimination is not possible. So that we have to think of the nucleic addition, nuclear substitution. And as those are competing reactions, if one fails, the other thing will occur. The other thing will occur, right? So you have to write the mechanism here as a nuclear substitution. Which kind of nuclear substitution? Which kind of nuclear substitution? As it's a primary halide, this carbon only containing one R group, no? As is a primary halide. Primary halide, nuclear substitution should be one step. One step nuclear substitution, this into, right? So the one step nuclear substitution is into should occur with this one. So the product is going to be product is this one, the nuclear substitution. That means instead of the halogen, you are just substituting your nucleophile, the OH here, nuclear substitution. It should be done in a one-step mechanism. Right now, what about this thing? So you are not using alcoholic medium here. Ethanolic medium is not used. So as ethanolic medium is not used, right? No alcoholic medium. That means normally aqueous mediums are used, right? That means aqueous medium is used. If special medium is using, they should indicate, but they haven't indicated like this. So normally aqueous KZN is used, right? So we are thinking of nuclear substitution. So as this one is kind of a tertiary carbon, right? It is going to be two-step nuclear substitution, right now. So the product is this. Nuclear substitution means just substituting your nucleophile instead of the halogen, right? With this one as well, the same procedure. This one as well, the same thing, right? So nuclear substitution. As this is this carbon is kind of tertiary. Again, two-step SN1. So with this as well, you are supposed to come up with the nuclear substitution product. Instead of BR, you have to connect this nucleophile, right? This carbon will connect with this, right? This will leave. Okay, so that is how the products are formed. Things are clear, no? So you can write the two-step mechanism for this one, right? This is all about the nucleic substitution and the elimination reaction mechanisms of the alkyl halides, right? So this is a kind of a special note or special discussion about those things. Some further topics have been discussed, right? Okay, so with this one, let's end the lesson for today, right? It's a short lesson, right? So go through these things as well. These are very special ones which will be asked in your A-level exams, even in the MCQs, right? Practice to write the mechanisms as well, right? So that's it for today. See you with the next lesson. Goodbye then.